Hello students, now it's time for us to start with the sums based on speed, distance and time. But before we start with the sums, let us first go through on the kind of formulae that we will be using for speed, distance, time and what should be our approach when you see a sum based on speed, distance and time, right? So first have a look at the formulae. These are the three formulae. We need to use one of these formula in the sum, right? So let's do it. The very first formula is speed is equal to distance upon time. We all know this formula. From this formula, we can say distance is equal to speed into time, right? And also time is equal to distance upon speed. So we need to use one of these formulae in the sum. But now the question is, how do we understand which formula is to be used? So always remember this. Now see, there are three things: speed, distance and time. Now out of these three things, one will always be given in the sum. Say for example, there is a sum where the distance is already given to us. Okay. One will be asked, find the speed, say for example. Now if the question is find speed, we will assume speed as x and y, right? So say distance is given, speed is assumed. So what remains now? The time. So whatever remains, we need to use the formula for that. Now because the time remains, then we need to use the formula time is equal to distance upon speed. So always remember this. One of the three will be given to us. The other one is to be assumed. And whatever remains, for that we need to use the formula. So if time remains, use the formula time is equal to distance upon speed. Distance remains, distance is equal to speed into time. Speed remains, speed is equal to distance upon time. So three things, one will be given, one we will be assuming, and whatever remains, we need to use the formula for that. So remember this, right? Let's go through a sum, a very, very easy sum. The sum is, out of 1900 kilometers, Vishal travelled some distance by bus and some by aeroplane. Bus travels with an average speed of 60 kilometers per hour and the average speed of aeroplane is 700 kilometers per hour. So speed is given, right? The speed of bus is also given, speed of aeroplane is also given. It takes 5 hours to complete the journey. Find the distance Vishal travelled by the bus, right? Let's go step by step. There are two things. There is a bus, there is an aeroplane. Speed is already given to us. Now let's form the equation. Let's see how. The question is, Vishal travelled some distance by the bus and some by the aeroplane. So let the distance travelled by the bus be x kilometers because it is asked, and let the distance travelled by aeroplane be y kilometers, right? So distance is assumed. Speed, as we all can see, is already given. So what remains? Time. So in this sum, we know that we are supposed to use the formula for time. As simple as that, right? So distance travelled by the bus is x kilometers, distance travelled by aeroplane is y kilometers, and it is given that the total distance is 1900 kilometers. Now because the total distance is 1900 kilometers, the first equation already we know x plus y is equal to 1900, right? Let's see some distance, say A to C is travelled by the bus, and say C to B the distance travelled is by the aeroplane. So this is x kilometers, distance travelled by the bus. This is y kilometers, the distance travelled by the aeroplane, and the total distance is 1900 kilometers. So as I said, the first equation is x plus y is equal to the total distance, which is 1900, right? The second condition would definitely be on the basis of time because that remains, and for that the speed is already given to us. So the speed of the bus is already known, the speed of the aeroplane is also already known. So let's use the formula and get the time taken by the bus and the time taken by the aeroplane. Let's do it. Speed of the bus is given as 60 kilometers per hour, as you all can see in the table. Speed of the aeroplane is given as 700 kilometers per hour, as you all can see in the table. So the time is equal to distance upon speed. We need to use the formula for time because distance is assumed, speed is given. So now let's find time by using the formula time is equal to distance upon speed. So time taken by the bus will be x upon 60, time taken by aeroplane will be y upon 700. The total time is given as 5 hours. It takes 5 hours to complete the journey. So the time taken by bus plus the time taken by aeroplane is equal to the total time. So your equation is x upon 60 plus y upon 700 is equal to 5. As simple as that. Now let's solve this equation. 60, 700, let's take the LCM. We all know how to find the LCM. The LCM of 60 and 700. Let's see how to do it. 2 30s are, 2 350s are, 2 15s are, 2 175s are, 5 3s are, 5 35s are, 5 3 as we do in LCM because 3 is not divisible by 5 or something, and 5 7s are. Now let's find the LCM. 3 1 3 7 7 1 1. Right? Now let's find the LCM. How do we do it? 2 into 2 into 5 into 5 into 3 into 7. So your LCM is 2100. So let's multiply throughout by 2100. We get 60 and 2100. Let's cut. We get 6 ones are 6 35s are. So 35x. 7 ones are 7 3s are. So 3y is equal to 5 into 2100, that's 10,500. Let this be the second equation. So your first equation is x plus y is equal to 1900. Your second equation is 35x plus 3y is equal to 10,500. Let us solve these two equations by the method of equating the coefficients. Look at the coefficients of x. The coefficients are not the same. You cannot eliminate x. Look at the coefficients of y. The coefficients are not the same. We cannot eliminate y, but we can definitely make the coefficients of y same, right? And to do that, we'll have to multiply the first equation by 3. So let's do that. When we multiply the first equation by 3, we get 3x plus 3y is equal to 5,700. 1900 into 3, right? Let this be the third equation. Now look at the second equation and the third equation. In the second and the third equation, the coefficient of y is the same and signs are also the same. So we will have to subtract the two equations. Subtracting 3 from 2, write the second equation, write the third equation, subtract by changing the signs, right? We all already know this, so we can quickly go through this. 3y gets cancelled. We get 35 minus 3, that's 32x, and 10,500 minus 5,700, that's 4,800. So you get x is equal to 4,800 upon 32. 32 ones are 32 150s are. So x is equal to 150. Once we get the value of x, the question is find the distance Vishal travelled by the bus. So distance travelled by the bus is x kilometers. X is equal to 150. We are not supposed to find the distance travelled by aeroplane. So we are not interested in finding the value of y here. So once we get the value of x as 150, just write the final answer. Therefore, Vishal travelled 150 kilometers by the bus. As simple as that.